having fun today? Okay, cool. We all ate barbecue for lunch, so I think people might be getting a little sleepy. So I'm going to kind of walk around and drive whoever's running the camera crazy and see if that works. And if I get scared away by feedback, then I'll retreat to the podium. But in the meantime, I'm not here. Okay, so we're going to start by scaring the shit out of you. March 2012. This is a posting by Tom from GitHub. Public key security, vulnerability, and mitigation. Most people probably saw this post. GitHub was hacked, and there was a risk that anybody could associate any public key with any GitHub repo, which is basically the worst case scenario. It meant that anybody sufficiently knowledgeable and motivated could take access of any source code on GitHub. Big problem, right? Everyone had to verify all their SSH keys. This was a big security issue. All right, fast forward. January of this year, rubygems.org, hacked. YAML deserialization vulnerability permitted potential remote code execution on the RubyGems servers. They had to verify, I don't know how many it was. Does anyone know? Hundreds of thousands of gems, basically every gem ever pushed to make sure that it wasn't tampered with. And then this was a little gift from the gods as I was preparing my presentation. On Tuesday, Scribd hacked users, email addresses, and hashed passwords stolen from Scribd. So I just added this slide. And now they're communicating to their users that they need to take precautions, they need to reset their password. But these are much bigger issues than the post will let on, because how many of these users are using the same password for their email that they're using for Scribd? And how many people have bank account stuff that goes to their email, right? So this is probably organized crime, stealing people's passwords, stealing their credit card information, making real money off this. And this could happen to you. So we're going to look at how to prevent that. My name is Bryan Helmkamp. I'm the founder of Code Climate. And today we're going to look at what you need to do to make sure you don't end up the next person having to write a very unfortunate blog post like that. We're going to look at how to secure your Rails application. So I gave this talk a couple weeks ago in Uruguay, and they did live translation from Spanish to English. And apparently, I have a friend whose wife is a translator, and he tells me that it takes 20% longer to say everything in Spanish when you're translating it live from English. So the feedback I got after giving this talk was, that was fantastic, and you almost killed the poor translator woman by going too fast. Apparently, she was having difficulty gasping for air because I was going basically full speed English, and that translates 20% up into Spanish. So instead of 10 attacks and countermeasures, we're going to look at 7. When I say attacks and countermeasures, these are the things that you need to be aware of, you need to be looking out for if you're going to secure your application. The attacks tend to be grouped into patterns. So we're going to look at patterns of attacks, what they mean, what they can do with it, and then how to secure your app. We're going to go pretty fast anyway, even though it's only 7. So number 1, session hijacking, okay? Let's take a look. The victim has a trust relationship with the server that's embodied in their session. Now, the session could be just a session ID, or it could be the session itself. You could have the user ID encrypted in the session like Rails does. It doesn't really matter. The point is that the way that the server knows who you are is by the session that's sent from the user's computer to the server on every request, right? Everyone's kind of familiar with this. So a session hijacking attack, that's when an attacker is able to observe the session information and then make requests to the server with that information attached. And the server has no way to know that, or no good way to know, that the attacker is making the request now and not the user. So the attacker has the effect of being able to take action as the user. So you remember a few years ago, this great tool called Firesheep came out. And if you haven't seen Firesheep, it's a Firefox plugin that basically you install, and it lets you easily hijack sessions on a number of popular websites. You go on a public Wi-Fi network and you point and click and say, I'd like to log into Facebook as this person. And it was great because it was an inflection point where it brought a lot of visibility to the session hijacking issue. Before that, people were kind of like, well, yeah, you could do it, but it doesn't really happen all that much. And now it's like, no, like this is real. This is a problem. So the risk is you steal the user's session, and then you take actions as that user. Let's look at what you can do about it, okay? So for countermeasures, there's 4 things we're going to talk about. One is forcing SSL everywhere. There's some flags that you can set on the cookies that you're communicating to the user's browser to help you. The strict transport security header, which is a totally different thing. I'll look at that in a sec. And the 4th one is kind of application specific, which is requiring the password from your users when they take sensitive actions. So if you have something that's really important, like let's say buying $50,000 worth of stock, or changing your password, or changing your email address in a way that then you'd be able to take over the account, those are good actions to require the user's password on. Because remember, in a session hijacking attack, you can make requests to the server as if you were the user, but you don't know their password. So if you require the password for that, you've got a fail-safe in the case where you do have a session that's hijacked. They can't take maybe the most critical actions on your site. So Rails makes it really easy to force SSL everywhere now. And I recommend this. This is not the default, but I think it should be because most Rails applications tend to have some sort of user system. How many people run a Rails application where people log into it in some way? Yeah, pretty much everybody. That's why this should be the default. Now, you can make this case that content management systems, maybe they don't need that kind of thing. But I don't really buy it. Like, if you have users logging into your system, consider going SSL everywhere. I don't know of any good reasons not to do this. People used to talk about performance and all this stuff, but I think that's kind of just washed away at this point. And you can see a lot of the big sites are now going SSL by default. If you have a little site, you should certainly do it as early as possible. So we talked about the secure and HTTP-only flags on the cookies, right? When your Rails app sends down your session, you want to make sure that it includes these two flags. And I'll explain what they do. The secure flag on the cookie tells the browser, only send this cookie over a secure channel. If you're making a request over HTTP, don't send the cookie, which is not the default. By default, it will go up over both. But if you include the secure flag and you send the cookie down over HTTPS, the cookie will only be transmitted back and forth over HTTPS. The HTTP-only flag is kind of a protection against cross-site scripting, which we'll look at in a little bit, but it tells the browser, JavaScript doesn't really need to be able to read this cookie, because that would probably only be for malicious reasons. We're not doing that in JavaScript, so don't let the JavaScript do that. So what you want to do is, I think Rails will do this by default depending on the version, but make a request to your server, go into Web Inspector, and confirm after you've got SSL turned on everywhere that these two flags are present, okay? This takes a few seconds. The strict transport security header is a little bit newer, and this closes a hole in the SSL implementation of websites. So what this tells the user's browser is if somebody types, when someone goes to your site, they don't type in https://yoursite.com. Only nerds do that. Real people type yoursite.com and hit enter, or they go to Google and search for your site and click the first result. So what strict transport security does is it tells the browser all communication to this site is supposed to be over SSL. So if you type yoursite.com into Chrome and hit enter, don't make a request to HTTP first and then wait to be redirected. Because if somebody can get in between there, they can take over the whole channel and substitute in their own unencrypted version of the site. So Chrome, if you use this, will make SSL requests always. And if your certificate is invalid, let's say someone replaces your certificate with an unsigned certificate, self-signed certificate, Chrome will actually refuse to let the user make requests to the website. So if you're doing forced SSL correctly, this is another layer of protection, and it's very easy to add. There's an expiration on this, because Chrome needs to know how long do I pay attention for this. So use the strict transport security header. OK, number 2, brute force attacks. I need water. So brute force attacks. This is all about hashes. So none of you, because you are at a Ruby conference and you are knowledgeable, awesome people, store your passwords in plain text, right? You don't store them in plain text? OK. But how do you store them? You probably have some sort of hash function that you're storing them with. And we'll talk about the differences depending on which type of hash function you're using. Now, if you go back about 7 years or something when people were starting to build Rails apps, most passwords were encrypted with like SHA-1 or MD5. Not encrypted, hashed with SHA-1 or MD5. And if you're doing well, you were adding salt to it. The problem is brute force. Right? So even if you're doing salting the passwords, you're adding salt onto the password before you hash it, that protects you against rainbow tables, but who cares if you can brute force it? To determine how vulnerable you are to brute force, this is Scrib, right? This is the Scrib example from this week. How long do those users have before their passwords get cracked? That's the question. If you're a Scrib member, and I'm sure a lot of you are, that's the question that should be on your mind. And so the way you do brute forcing like a SHA-1, so Scrib said, well, our passwords were salted and hashed, but they didn't say which hash function, which leads me to believe, to speculate that perhaps they weren't using the most secure hash function, because then they might mention that. Perhaps they're using SHA-1 or MD5. So let's assume that they are guilty until proven innocent, and they're SHA-1ing them, and then they're salting them. Or salting them and then SHA-1ing them. How many guesses per second can you try to brute force a password that's encrypted like that, right? So in 2009, Ingenieur did a programming challenge. And part of the programming challenge was computing SHA-1s as quickly as possible. And there were teams that worked on this to try to win the challenge, right? And the winning team assembled around maybe 20 computers that they put together and just tried to compute as many SHA-1s as possible. So does anybody want to take a guess as to how many SHA-1s they could compute per second in 2009, some amateurs, to win an engineered programming challenge? And the closest without going over gets a Code Climate t-shirt. Tell me your size, and I'll bring it for you tomorrow. Yes, throw out guesses. What?
10,000?
10,000. Anyone else? A million? Any other guesses? What?
7 billion.
7 billion. OK. So we have 3 guesses. The answer is 3 billion per second. So 7 billion was over. You win, I believe. So let me know your size after the talk. So if you can compute 3 billion SHA-1s per second, this is how long your script passwords are good for. This includes all upper and lowercase letters, all numbers, and all symbols. This isn't just like remedial, super small character set. Up till 8 characters in 2009 with that team, they could have cracked every single one of those in 28 days. On average, it would be faster than that, but that's if you guess it on the very last one. I'll do questions at the end. Thanks, but save it. So you can see this is a big problem. So how do you fix that? The problem is that SHA-1 and MD5 are designed to be really, really fast. And then you can use them really, really fast, and that creates brute force problems. So you need to use an adaptive hashing function like bcrypt or scrypt. And those are designed to be very slow. So instead of doing 3 billion per second, you might be able to do 1,000 per second. And that just has a dramatic impact into how quickly you can guess people's passwords. So Rails makes it really easy to use bcrypt. You can add the bcrypt Ruby gem, and they have this has secure password kind of macro at the class level, which provides a nice accessor for setting the passwords and then validating them. Some of the authentication frameworks like AuthLogic and RESTful authentication, they might use bcrypt, but you should know, even if you're just outsourcing authentication to a gem, 1, make sure it's up to date and patched, because all of those gems at some point have had security vulnerabilities. But 2, know how your passwords are being stored. And if it's MD5 or SHA-1, if it's not bcrypt or scrypt, get on a migration strategy. OK. Insecure direct object reference is just a really fancy way of saying something that's really simple. So let's take a look. This is just kind of like a standard RESTful controller example where you've got an account and you've got messages. And the messages are nested under the account. So this is how I probably would have written this back in the day when I was first experimenting with RESTful stuff. And you look up the account and you look up the message. So what's the problem here? Anybody?
Make it find a message will let you find any message?
Yes, it'll let you find any message, right? So the problem is, if you're counting on the fact that you have the right account to make sure that you have the right message, that's not going to do you any good. And even if you don't care, let's say it's like a public forum where anybody can see anything, you still have a problem because you can construct a URL where you render a given message under someone else's account. So if I post something to my blog, then I can construct a URL that looks like you posted it to your blog and send that out and say, hey, look what this guy posted. Right? So it's a problem either way. The fix for this, the first fix is pretty simple. You just scope under the association, and that will scope the fine, right? So I shied away from this before. I was like, well, this doesn't seem as clean, and log Demeter, blah, blah, blah. Now it's better. The next thing is, the other problem is authorization. And when I say that, so just because you're looking up the right a record properly doesn't mean that the user has permission to see it. When I see a bug like that, I see a failure of an authorization to be enforced. So what I want to teach you today is just a little bit of code that you can use in your applications that I've used multiple times to make sure you have authorization being enforced throughout your application. So this is something you can take back to work next week. So this is a module called an authorization system. It just has a couple things, right? It's got an authorize method, which yields to a block. And then if the block returns something that's falsy, it's going to raise a not authorized exception. Now, depending on your context, you might do different things with that. You may display a nice message or a not so nice message. And then there's this validate authorization checked method, which we'll talk about in a little bit. So to include this into your application controller, you just include authorization system. You add an after filter, which will run after all the code from the controller is executed. And you'll use it like this, to go back to our example. So you say authorize bang, and you say current user can view the message. Now sometimes people use like can and all that stuff for this. I don't think you need anything that complex to get started. So don't feel like you need to add a gem. You can just add a method that determines that, right? Start small and then add more complexity only if you need to. But you put that in the authorization bang method, and if that returns false, it's going to raise a not authorized exception, and it's going to halt the flow of the program, and it's going to return whatever response you designate for that failed authorization. But the nice thing is, you go back. We record an IVAR called authorization check when the authorized bang method is called. And the reason we do that is if it's never called, we know it, right? Because that's going to be nil, because as new instance of the controller, it's going to start as nil. And then when we hit our after filter, and we do validate authorization checked, we can raise an authorization not checked exception. What that does is it forces the developer and every action to figure out what the authorization scheme should be, even if it's just everybody should be able to access this page, because it's the terms of service and everybody should be able to see it. But if you have to think about it, eventually one time you're going to forget, right? You've got 300 actions, one of them you're going to forget to check authorization. So if you use a little bit of code like this, you've created a secure default in your application where you have to enforce authorization, or at least think about it in development time. The authorization not checked exception is probably never going to get thrown on prod, but it will remind you when you're developing that you need to think about the authorization policy for this action. So I like to use something like this, and you should too. The fourth type of attack we're going to talk about is mass assignment. This is kind of a Rails-specific thing. A lot of the other ones apply to PHP, Python. This is where convention over configuration strikes back. So most people are familiar with adder protected and adder accessible. Just to review, adder protected is a blacklist system. So you can say the admin field on a user is protected. The problem with this is even if you do it right the first time you add adder protected, eventually you're going to add another sensitive field, or even just rename it, right? You rename it from admin to super admin. But you forget to update the adder protected declaration, and now you've introduced a vulnerability when you weren't even thinking about it, right? So adder accessible is better. It's a whitelist system. You say these are the attributes that can be modified, but it still has a couple issues. The big one is that safe attributes can vary by context. So just because you have an account record, and the user should be able to control the account's email address and the account name, you might have a field on the account for the notes for the customer service representatives. And you don't want the user to be able to update the notes that the customer service representatives are supposed to update. So there's now facilities in adder accessible to help with this. They've got like this concept of context, but in my mind it gets a little complicated and a little bit gnarly, and it's a smell that maybe we're not doing this the right way. The other thing is adder accessible will still often make testing a pain, right? Because now you have to switch to the block form of initializing all these things and do them one line at a time, whereas you used to just be able to pass in whatever hash you want, right? So people have felt that pain. So that's not fixing adder accessible. But in Rails 4, they have this new thing called strong parameters. And strong parameters is by the default in Rails 4. It's also available for Rails 3. So I recommend that people check it out for Rails 3, especially if you're not using these kinds of things. But we'll look at how it works. So in this case, we're updating the user based on the params. And we define this user params method down at the bottom of the controller. And that does two things. It does a permit and a require. So the permit says, it's basically just like hashing into the params, except it has an extra behavior that if the user key is missing, it's going to return a 400 invalid request response down to the user right away. So that prevents that case where somebody sends a request that has like no params in it, and you end up with like undefined method brackets on nil because you're hashing into a hash, right? You've all had that hit your production servers. Well, this will protect you against that, so that's just kind of a convenience. But then the permit method is much more interesting because that's going to slice your params and ensure that only the specific params that you name are allowed to be passed through. So this is going to be driven by the form fields that you have on your page, right? So based on the fields you render, you're going to say just those fields are what should be able to come through the user params in this particular point. So you're going to protect yourself against mass assignment issues, and you have that contextual thing sort of already covered because your admin controller that manipulates profiles can just permit a different set of parameters, and you don't have anything that's going to slow you down in your test context. So if you pass in something that's not expected, if you pass in params directly to a mass assignment method, and you haven't said which field should be permitted, you get an error by default. So this is a secure default, and that works by sort of wrapping the params. It only works with params. Everything else is allowed through. So I recommend you use strong parameters. The fifth issue is cross-site request forgery. So this one's a little complicated. I'm going to draw it out. So you have a victim, and you first trick them into making a request to a malicious site. So maybe you send them a link or an IM or something, get them to click on it. So they just make an innocuous request to a malicious site. Part of the contract of the web is supposed to be that by just browsing to a site, you don't get hacked, right? Like, and people don't, after a long time, don't necessarily trust that, right? They get afraid to click links because it's going to hack their computer, and it used to be like ActiveX controls would install and everything, right? But you should be able to click on whatever damn link you want without worrying about your stuff getting hacked. But if a site is vulnerable to cross-site request forgery, that's not the case. So once the request is made to the malicious site The malicious site is going to send back an HTTP response. It's going to conclude this image tag, right? This image tag points at the target site, and it has a URL. But that URL has the semantics of somebody buying stock. It's not actually an image. It's something else, but the browser doesn't know that. So the browser, because this is the contract of how the web works, will make a request from their computer to the target site at that URL, and importantly, it includes the cookies, right? Because the cookies are not based on where the image tag was included. It's about where the image tag is going. And so it includes the session. So the target site interprets that, potentially, as a request to purchase that stock, and it puts it through, and then, just by clicking on that link, there's been a request forged across site. So that's CSRF, or CSRF. Now, Rails has pretty good protection against CSRF. It has the protect from forgery directive that you can put in your application controller. This should be there. I keep running into apps that don't have this. I'm not sure why. I think like back in the day, it used to not sort of work super cleanly with JavaScript, and people would just comment it out and say, ah, fuck it. But go back and make sure that that's there. You want to use the CSRF protection. It does work with JavaScript now. They have the jQuery, Rails jQuery stuff. It just adds it all in. You don't have to think about it generally. And you also need to make sure gets are safe, because Rails CSRF protection does nothing for gets. There's a comment in the source code that says gets are supposed to be safe. Punt. So make sure your gets are safe, and also make sure you're not routing anything with multiple HTTP verbs where you're always posting to it, but it's available over a get, because an attacker will just hit it over a get even though you're not. So make sure you don't have leaky routes, right? OK, SQL injection. How many people here think Rails is vulnerable to SQL injection? That's like a quarter. I do. You want to see? So this is what we are used to doing, right? We do a quick query by project name. And the contract with Rails is that whatever comes in param's name, whatever it is, you can't inject SQL. Because we're going to take it straight from the params and hand it straight to active record. And that works, or at least we all believe that it works. And it's just like a principle that everything's built off of. So depend on this. Don't construct SQL strings yourself, because you're going to screw it up. Let Rails do it. If there's a vulnerability that's discovered in Rails, smarter people than me will patch it, and I'm going to upgrade, right? So that's how I'm going to deal with that. But let's look at SQL injection. So the pluck method was added recently. And pluck returns an array of a single column from a relation. Now, if I'm trying to take a shortcut, let's say I need to return order totals or subtotals, depending on the context, right? Maybe I say, you know what, convention over configuration, I'm just going to take the param and pass it to order pluck. And the param will be either total or subtotal, and it will return the proper array of values. But I know that this might let somebody pull back other values off the orders table, but the orders table isn't that sensitive, so who cares? This will save me some code. It's in the admin area, right? Who cares? The problem is, if you look at the active record docs, the name for that first parameter is column name. That's what it's called. It's the column name variable. However, it doesn't have to be a column. It can just be SQL. It should be named arbitrary SQL, do whatever you want with it. But that would be long. So if I send your server a request where I set params column to password from users, now I've totally changed the meaning of that pluck. And I've plucked every password off the users table, a completely different table. And the dash dash means comment, so it ignores everything after that. All right, let's look at another example. Calculate. So you might say, OK, well, I'm calculating off orders, so maybe whatever I put in that, again, column name parameter will just indicate what values I'm summing. So that's a pretty, it could allow someone to do something malicious, but not that big a deal. However, if you know how these queries are constructed, and everyone does because it's open source, you can insert a value that says, OK, I actually want a specific value of a specific table, which is different from orders, and I'm going to actually add where clauses to make sure I get exactly what I want. And now I've used this aggregation to pull whatever data I want back from the database. So it's SQL injection. You have to know the active record APIs that you're using. If you haven't, if you're using some of these less common APIs like calculate or aggregate and pluck, you need to know what they allow and what they restrict. So there's a website. This is a really good thing to check out called rails-sqli. That's for SQLinjection.org. It was done by Justin Collins, who's really smart. He's a member of the Twitter application security team. And he goes through every method in the active record API, the arguments that it takes, the options that it takes, and writes out exactly what you can do from a SQL injection standpoint. So it's worth a look. Number 7, cross-site scripting. So here's how cross-site scripting works. The attacker sends a malicious script into the target website. Somehow, in a param, they put it in the database, whatever. Then the target website sends that script down to the user. The user's browser interprets it. And once you can run JavaScript, once you can run JavaScript in the context of a user's browser, you can do all sorts of bad things, right? Most common would be stealing the cookies. You can also have the user take actions. Like, you've broken the entire trust model of the web. So that's cross-site scripting. And this is considered kind of like the biggest web application security risk out there today. It's super pervasive. There's all sorts of cross-site scripting vulnerabilities you can find and exploit. And they're a really big deal. So cross-site scripting is something you should be afraid of. There's a few different countermeasures you can take. Now, in Rails 3 and up, there was this Rails XSS feature that was added, and that's on by default in Rails 3, so you want to make sure you're using that. And that's the stuff where it'll escape everything by default unless you declare that it's safe, and then it will let it go through raw. If you're doing user-generated content and people are submitting HTML to you, maybe you're running a form, you need something a little bit more complicated. You need something to make sure that you're only allowing safe HTML elements and attributes through. So Loofah is a gem that can do that for you if you're accepting HTML from someone that's untrusted and trusts nobody. And then content security policies is kind of a much newer, really cool thing that I'm going to talk about a little bit tomorrow, but I can't cover today if I make it into the lightning talks. So the risks are, even if you're on Rails 3 and you're using the Rails XSS stuff on by default, you want to really be careful with raw and HTML safe. Those methods are saying like, hey, Rails, I know what I'm doing. Whatever's coming through here, this is safe. I got this. So don't you worry about it. Send it straight down to the browser. So usually when I find cross-site scripting issues in Rails 3 apps, they're places where someone's using the raw or HTML safe helper improperly. They're not enforcing it themselves, and then they're marking it as safe. So that'll create holes, right? Also, link to href attributes can be used to inject script. I'll show you that on the next slide. So link to, right? People don't realize this. Let's say you have a profile on a social networking website, and that lets you supply your homepage. Just as a convenience, it generates a link to the user's homepage. The user can control the homepage URL field because it's their homepage, right? They're supposed to, right? But if you put link to, and then for the href, you say user.homepage URL, you might not realize it, but you can put script there, right? JavaScript colon. Remember these links that we used to use like 8 years ago? All of our links were on-click and JavaScript colon this and that. We've all moved to an unobtrusive JavaScript. But Rails will just let this through. There's nothing in Rails that's going to save you from this. And I think this is a crappy default, and Rails should not let you do this. Because most of the time, 99% of the time, the stuff you put in the href is not supposed to be JavaScript. But an attacker is going to use that to put JavaScript in there. So you have to be very careful with what you put in the href attribute for link to. OK, so that's the first part of the talk, which are all the attacks and countermeasures. How am I doing on time? No? 34. I'm over time? Oh, shoot. OK, we'll go fast to this. So Brakeman. How do you get a handle on all this? Brakeman is a gem that you can install. It's super easy. It does static analysis for security vulnerabilities. You run it on your application, and you get a report like this. It finds basically all of the types of issues that I've described. Brakeman tries to find them for you. It's not perfect. There's false positives. There's false negatives. But if you've never run it against your application, I bet you that it will find something that is worth fixing. If you try it, and if I'm wrong, I will buy you a beer. How's that? And make that with everybody in the room, but not on the live feed, because that could be a lot of beer. But I think it will do. All right? So try this on your application. Let me know what you come back. The company that I run, Code Climate, we just launched a feature called Security Monitor, which is based on Brakeman under the hood. So if you're too lazy to do Brakeman and you want somebody to run it for you, we can run it for you for a nominal fee. And we will email you if something new comes up. That's kind of the big value add, is that you run this once, something new comes up, we can let you know about it. And we'll give you a dashboard that shows all the issues that are in your application. Last thing, if you're interested in content like this, there I think is not enough readily available content like this in the Rails community. So railssecurity.com is a free ebook that I'm working on that's going to be Creative Commons licensed and published that covers Rails security issues, Ruby security issues, web application security issues. We're trying to be very comprehensive, very in-depth with threats and countermeasures, just this kind of stuff. If you're interested in this, toss your email address in on railssecurity.com. The more people who put their email address in, the more I will work on it. And the faster it will be out. So help me out there. And that's all I've got. Thank you.